Hello, dear students. Today we are going to learn about the operations on rational numbers. And we have learned last time that rational numbers are numbers which could be written as the quotient of two integers. So today we will learn how to add, subtract, multiply, and divide decimals as well as fractions. This is Teacher Mary Jane, and I hope that you learn from our discussion. All right, so we have here examples on how to add and subtract similar fractions. Okay, what does it mean when we say similar fractions? So these are fractions which have the same denominators. All right, so we have here a rule. To add or subtract similar fractions, we simply add or subtract the numerators, write the sum or difference over the common denominator. And of course, we reduce the answer to lowest term if needed. Okay, so what we have to consider in adding or subtracting similar fractions is the numerator. And then we just copy the denominator. Okay, let's have examples. So example A, we are going to add 3/5 and 1/5. So if we are going to add that, so we write it first in horizontal form, or you can write it using vertical. You can write them vertically. Okay, it's up to you, whichever is more comfortable or easier for you. Okay, now as we have said in the rule above, we simply add or subtract the numerators. So we have 3 plus 1, that is 4. And then our common denominator is 5. So the sum of 3/5 and 1/5 is 4/5. Okay, that is the answer. Now how about for subtraction? So we are going to subtract 4/10 minus 2/10. So again, we write it in any way that we want. So for the solution, we are going to write them horizontally. So we have 4/10 minus 2/10, and then we copy first our common denominator, which is 10, and then subtract our numerators, since subtraction is our operation here. So 4 minus 2 is equal to 2, and we can still simplify these numbers. We can divide 2 and 10 by 2, yes. So 2 divided by 2, we cancel, and we have 1. And the next 10 divided by 2 is equal to 5, so we cancel 10 here and write 5 below or beside it. Now we rewrite, so we have 1/5 or 1/5. That is the difference between 4/10 and 2/10. Next, so this time we are going to look at problems involving mixed numbers with similar fractional parts. Okay, so mixed numbers means that we have a whole number included. Add or subtract the numerators and write the sum or difference over the common denominator. And of course, we reduce the answer to lowest term if needed. But what will we do with the whole numbers? We simply add or subtract them as well. Let's have an example. So we have here example A. Add 4 and 1, 9, and 5 and 2, 9. So we write them horizontally, and we have already added here the whole numbers. So 4 plus 5 is equal to 9. That's why we have here 9. And then the common denominator is 9. So we write there the denominator 9. And of course, we add our numerators. So we have 1 plus 2 is equal to 3. But 3 and 9 have a common factor, which is 3. So we can divide 3 and 9 by 3. to simplify this fraction. So 3 divided by 3 is equal to 1, and 9 divided by 3 is equal to 3. We rewrite it. Our final answer is 9 and 1/3. Example B. So we are going to subtract this time. Subtract 23 and 7 over 28 minus 2 and 2 2 over 28. Okay, so we write them horizontally again, and there is the difference between 23 and 2 for our whole numbers. So 23 minus 2 is equal to 21. So that is our whole number. And then copy our common denominator, which is 28. Okay, and 7 minus 2 here is equal to 5. And 5 and 28 do not have any common factor. That's why our final answer is 21 and 5 over 28. Next, so to add or to subtract a fraction or a mixed number from a whole number. Okay, so this time we have a whole number as the minuend or the addend. Rename the whole number as a mixed number whose denominator is the same as that of the fraction. Then subtract in the same way you subtract fractions or mixed numbers. We reduce the answer to lowest term if needed. Okay. So if we have a whole number, we simply write it as a fraction, but its denominator will be the same with that of the denominator of the fraction that we are adding or subtracting. Here is an example. So we have here a whole number 5. We are going to subtract 2/3. And what are we going to do? We can express 5 as 15 over 3. Okay, because 15 divided by 3 is equal to 5. Or we simply multiply our, what is this? Our denominator, the denominator of the fraction, to that of our whole number. Okay, so 3 times 5 is 15. And of course, divide it again by the denominator for us to get 5. Okay, now we can already apply what we have learned earlier. So simply copy the common denominator, which is 3, and then subtract the numerators. So 15 minus 2 is equal to 13. We can also express 13 over 3 as a mixed number. So how did we get 4 and 1/3? So let me show you how we've done that. Okay, so in the simplifying fraction or mixed fraction, we divide the numerator by the denominator, and then we divide. So 13 divided by 3 is equal to 4, and then 4 times 3 is equal to 12, and then the difference between 13 and 12 is 1. That is actually the remainder, but we express the remainder and our divisor as a fraction. Okay, so we copy our whole number 4 and then put the remainder in the numerator, and then the denominator is the divisor, which is 3. That's why the answer here is 4 and 1/3. Example B, subtract 9 minus 3 and 3/16. Again, we can express 9 as 8 and 16 over 16. So actually, we can also write 9 times 16 is, what is the product of 9 and 16? 16 times 9. So 9 times 6 is 54. 9 times 1 is 9 plus 5. So it can be 144 over 16. Okay, but since we have here a whole number, it is easier for us to simply write it this way. Okay, so we have 9 here. We just remove 1. Okay, and that 1 is equal to 16 over 16, since 16 divided by 16 is equal to 1, and then we are left with 8. Okay, so if you simplify 8 and 16 over 16, that is still equal to 9. Okay, to make it easier for us to subtract, we have made it 16 over 16 because our subtrahend is uh, the its denominator is 16. Okay, for them to be similar fractions, and we write it horizontally. So we already have there the difference, which is 5. 8 minus 3 is equal to 5, and then our common denominator is 16, so that will be the denominator, and then 16 minus 3 is 13 over 16. And since we cannot simplify further, so that is the final answer, 5 and 13 over 16. Right, this time we are going to deal with dissimilar fractions and mixed numbers. So we are going to add and subtract them. Okay, we have here our rule. It says there, to add or subtract dissimilar fractions, we change them to similar fractions by finding their least common denominator. I hope you are still familiar with the least common denominator. Add or subtract the numerators and write the sum or difference over the common denominator. And we reduce them if needed. Okay, so we have here the similar fractions 1/3 and 2/4. We are going to add them. Okay, so unlike what we've done a while ago, we cannot just add 1 plus 2 and then 3 plus 4. That is wrong. We have to make them similar fractions by finding the LCD. Okay, so for us to get the LCD, we list down the multiples of our denominators. So we have here the list of the multiples of 3 and list of the multiples of 4. And then the common number here is 12. That's why the LCD here is 12, least common denominator. After that, we will write the fractions as similar fractions. So we write 1/3 as a fraction wherein its denominator is 12. Okay, so how do we do that? We multiply 3 by a certain number to get 12, and that number is 4. Okay, and just like what we've done before, when you multiply by the denominator, we also have to multiply it to the numerator. So we have 1 times 4 is equal to 4. So the equivalent of 1/3 is 4 over 12. And then 2/4 on the other hand, so we have there 12 again as the denominator, and we multiply it by 3 to obtain 12. Of course, when we multiply 3 to the denominator, we have to multiply it with the numerator. So we have 2 times 3 is equal to 6. So the equivalent of 2/4 when we change the denominator into 12 is 6 over 12. Now they are already similar fractions, so we can add them. Okay, so 4 plus 6 is 10, and then copy the common denominator, which is 12. Now we can still simplify 10 and 12 because they are both divisible by 2. So 10 divided by 2 is equal to 5, and then 12 divided by 2 is equal to 6. So the simplified form, or the simplified form of the answer, is 5 over 6. That is our final answer to this example. Another example, so we are going to subtract 3/6 and 1/5. Again, we find the LCD. So you don't have to do this actually if you are already familiar with the LCD. So we just identify the LCD, which is 30, and then we change them as equivalent into its equivalent fraction. Okay, so 6 times what number to get 30? That is 5. Okay, so we have multiplied 6 by 5 to get 30. So we are also going to multiply 3 by 5. So 3 times 5 is equal to 15 over 30. That is the equivalent of 3/6. And then we have 1/5. So again, its denominator will become 30 when we multiply 6. So times 6 also to the numerator. 1 times 6 is equal to 6. Now that they are already similar, we can apply our operation, which is subtraction. So we have 15 over 30 minus 6 over 30. So 15 minus 6 is equal to 9, and then copy our common denominator, which is 30. And of course, 9 and 30 have a common factor, which is 3. So we can divide them both by 3. 9 divided by 3 is equal to 3, and 30 divided by 3 is equal to 10. So this is equal to 3 over 10, or 3/10. Okay, that is the final answer to this example. Next example. This time we have a mixed number. Okay, so we have 2 and 3/5 plus 1 and 2/8. So we disregard first our whole numbers and get the LCD of our denominators 5 and 8. So 5 and 8 are actually both have the same multiple, which is 40. The least common multiple of the two is 40, so that is their LCD. And then we rewrite our fractions 3/5 and 2/8 as fractions bearing the denominator 40. Okay, the pair of 5 here is 8, so we also multiply 8 to the numerator to get 24. And then the same with 2/8. So to make it 40, we have to multiply by 5. The same with the numerator. So 2 times 5 is equal to 10. Now we can add the numbers. So we have 2 and 24 over 40 plus 1 and 10 over 40. Don't forget to add again our whole numbers once you are done writing the equivalent of the fractions. So we already have the sum of the whole numbers. 2 plus 1 is equal to 3. And then we have 24. 24 plus 10 is equal to 34. And then our common denominator is 40. But this 2 can still be divided by 2. So we cancel. 34 divided by 2 is equal to 17. And 40 divided by 2 is equal to 20. That makes our final answer as 3 and 17 over 20. Here is another example for subtracting mixed numbers. Okay, so the LCD of 4 and 6 is 12 because that's the least common multiple of these two numbers. After that, we rewrite them as similar fractions. So 1/4, to make the denominator 12, we multiply by 3. So we multiply 3 also to the numerator. So 1 times 3 is equal to 3. And then our next fraction is 1 over 6. And to make the denominator 12, we multiply by 2. So 6 times 2 is equal to 12. And the same for the numerator. 1 times 2 is 2 over 12. So those are their similar, they are already similar fractions. We can include our whole numbers now and subtract them. So 3 minus 2 is equal to 1. And then 3, it's just the same, so let me use this. 3 minus 2 first, the whole numbers. 3 minus 2 is equal to 1. And then our the numerators, we subtract them. So 3 minus 2 is equal to 1. And then copy our common denominator, which is 12. We can no longer simplify this So that is the final answer to example D. Next, we will continue with multiplication of fractions. So how do we multiply fractions? It says there, to multiply fractions, we multiply the numerator to get the numerator, or we multiply the numerators to get the numerator of the product. Multiply the denominators to get the denominator of the product. Then simplify the product if needed. We have here an example. So we multiply 2/3 and 1/2. Okay, so we can write them horizontally. And as it says here, we multiply numerator by numerator. So 2 times 1 is equal to 2. And then 3 times 2 is equal to 6. And then we simplify them because they are both divisible by 2. So 2 divided by 2 is equal to 1. And then 6 divided by 2 is equal to 3. So the final answer here is 1/3. Example B, we have 2/3 and 1/5. We have to find its product. So we write them again in this manner. So 2 times 1 is equal to 2. 3 times 5 is equal to 15. We can no longer simplify them. So that is the final answer. Alright, so let's try to solve more examples. So we have example B. We have to multiply 2/3 and 1/4. So I will introduce to you another method of multiplying fractions, which is called the cancellation method. So in this method, we are going to cancel pairs of numerators and denominators that have common factors. Again, we will cancel numerators and denominators. We cannot pair up numerator to numerator or denominator to denominator. So we have here an example. So we have 2/3 times 1/4, and as you can see, 2 and 4 have a common factor, which is wait. Okay, 2 and 4 have a common factor, which is 2. That's why we will cancel these 2 and divide them both by 2. So if the result, when we divide 2 divided by 2, so the result is 1, and then 4 divided by 2 is equal to 2. Apart from those, there are no other pairs that we could cancel, so we multiply numerator by numerator and then denominator by denominator. So 1 times 1 is equal to 1, and 3 times 2 is equal to 6. That is the answer to example C. Next, we have example B. Multiply 3/4 and 8/9. Again, let us check if there are there is a numerator and a denominator that have common factors. So in this case, 3 and 9 have common factors, which is 3. So we divide them both by 3, and the result for this numerator, 3 divided by 3 is equal to 1. That's why we have 1 here. And then 9 divided by 3 is equal to 3. We could also divide 4 and 8 because they are both divisible by 4. So when we do that, 8 divided by 4 is equal to 2, and 4 divided by 4 is equal to 1. And there are no more common factors between the numerators and the denominators. So we are going to multiply this fraction. So we have 1 times 2 is equal to 2, and 1 times 3 is equal to 3. That means that the product of 3/4 and 8/9 is 2/3. It is already in its simplest form. So you can still use our previous method, but for you to easily, okay, so that you don't have to simplify and simplify, you'd better use cancellation method. another rule. Okay, same rule, but we will have another example. So in this case, our whole number is our divisor is a whole number. Okay, so we write it as well as a fraction. So we will have 2/3 divided by 6/1. After that, we change our operation into multiplication. Okay, right. So we change our operation into multiplication and then multiply it by the reciprocal of 6/1, which is 1/6. So for this, we can cancel 2 and 6 because they are both divisible by 2. And 2 divided by 2 is equal to 1. 6 divided by 2 is equal to 3. And we can now multiply. So 1 times 1 is equal to 1. And 3 times 3 is equal to 9. So the final answer here is 1/9. Next example. So for this example, we have this rule. To divide mixed numbers, rewrite them as improper fractions. Find the reciprocal of the divisor and change the operation to multiplication. And again, we use cancellation whenever possible. So here is the example. We are going to divide 7 1/2 by 1 1/2. So says there in the rule, we change the mixed number into improper fraction. Okay, so we have obtained 15/2 here by multiplying 2 and 7. So 2 times 7 is equal to 14 plus 1. So we have 15. And then copy the denominator 2. Next, 2 times 1 is equal to 1 plus 1. So we have 3/2. Next step, we change the operation into multiplication and write the reciprocal of the what is this? The divisor. Okay, so we will obtain 15/2 times 2/3 after doing that. The reciprocal of 3/2 is 2/3. Okay, and then we can cancel numerators and denominators with common factors. So 15 and 3 have a common factor which is 3. So 15 divided by 3 is equal to 5 and 3 divided by 3 is equal to 1. We can also cancel 2 and 2 as they are both divisible by 2. So that will be equal to 1. And then we can now multiply. So 5 times 1 is equal to 5. 1 times 1 is equal to 1. Again, since the denominator is 1, so we write it as a whole number. Okay, so the final answer here is 5. Now we have here a trial problem. Multiply 1/5 by, or divide 1/5 by 3 7/10. I will give you a few seconds to try and answer this problem. And then later on we will solve it together. Okay, let's check. So we have 1/5 divided by 3 7/10. We have here a mixed number, so we change it first into improper fraction. We have 10 times 3 is 30 plus 7, so 37/10. And then we copy our operation as well as our dividend. After that, we change this into multiplication. We copy our dividend first and then get the reciprocal of our divisor. So we will have 10 over 37. Now, do we have common factors? Yes, we have 5 and 10. Their common factor is 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. We can no longer cancel any pair, so we multiply 1 times 2 is equal to 2, and 1 times 37 is equal to 37. That is the final answer to this problem. Did you get it? Very good if you did. This time we are going to deal with operations on decimals. We have here steps on how to add or subtract decimals. So step 1, we write the decimals in columns and make sure to align the decimal points of the addends. Okay, let's have an example right away. So we have add 0.456 or 456 hundredths, thousandths I should say, 456 thousandths, 5 tenths, and 9,812 10,000ths. So we are going to add them all. For step 1, we have to align them in columns. So all of the decimal points should be aligned. So that is the result. After that, step 2, make the number of decimal places equal by annexing zeros to the decimal numbers. Okay, so for us not to be confused, we can annex zeros. Okay, so we can add a 0 here as well as zeros in this part. So that again we will not be confused. Okay, after that, let's proceed to step 3. Add or subtract the numbers from right to left in the same way you add whole numbers. Regroup if needed. Align the decimal points of the sum with the decimal point of the addends. Okay, so we start from the right. So we have 0 plus 0 plus 2 is equal to 2. 6 plus 0 plus 1 is equal to 7. 5 plus 8 is equal to 13. So carry 1. 1 plus 4 plus 5 plus 9 is equal to 19. So carry 1. And then we have 1 plus 0 plus 0 plus 0 is equal to 1. And then we align the decimal point of our sum by the decimal point of the 3 addends. Alright, so that is our final answer, or this is the sum of those 3 decimals. Next, we have to add 241 thousandths plus 1,221 10,000ths and 5. As you can see, 5 here is a whole number. Okay, so let us first align the 2, and then for 5, since it is a whole number, so its decimal point is actually here, okay, after the number. Okay, so we will now annex zeros, step 2, for us not to be confused. Alright, so that is the result. After that, we can add from right to left. So we have 1, and then 1 plus 2 is equal to 3, 4 plus 2 is equal to 6, 2 plus 1 is equal to 3, and then 0 plus 0 plus 5 is equal to 5. The decimal point will be here. So the final answer is 5.3631, or we read that as 5 and 3,631 10,000ths. Next, this time we will have subtraction. Subtract 1.9372 from 4.025, or we read it as subtract 1 and 9,372 10,000ths from 4 and 25 thousandths. Remember, it says there subtract from. It means that our minuend here is 4 and 25 thousandths, and our subtrahend is 1 and 9,372 10,000ths. So this is how our solution will look like. Again, we annex 0, And then we can now subtract. So 0 minus 2 cannot be, we will borrow from 5. So 5 will become 4, and 0 here will become 10. We can now subtract 10 minus 10 minus 2 is equal to 8. And then 4 here cannot subtract 7, so we will borrow from 2. So 2 will be 1, and 4 here will become 14. Now 14 minus 7 is equal to 7. Now we have to subtract 1 minus 3, but again we cannot because 1 is lower, so we will borrow from the next digit or from the digit to its left. But we have 0 here, so we will move and borrow from 4. Okay, so 4 will become 3, and then 0 will become 9 because supposedly it should be 10, but we will borrow, or 2 will borrow, and 1 will borrow, and it will become 11. Now we can subtract. 11 minus 3 is equal to 8. 9 minus 9 is equal to 0. And 3 minus 1 is equal to 2. And then our decimal point is here, aligned with the decimal point of the two numbers that we are subtracting. And here is our final answer, 2 and 878 10,000ths. Example D. So subtract 4 minus 2.75. Our minuend is 4. Subtrahend is 2.75. Again, 4 here is a whole number. That means that the decimal point is after the digit. We annex zeros for it to be easier for us to subtract. We cannot subtract 0 minus 5, so we will borrow from the next digit, but it is also 0, so we will borrow from 4. 4 will become 3, and then 0 here will become 9, and the 0 at the last place will be 10. Now we can subtract. 10 minus 5 is equal to 5, 9 minus 7 is equal to 2, and 3 minus 2 is equal to 1. The decimal point is here. Our final answer is 1 and 25 hundredths. So that is for addition and subtraction. This time we will move on to multiplication of decimals. To multiply decimals, multiply them as you would multiply whole numbers. So you should be familiar with multiplication. Count the number of decimal places in both factors. The total number of decimal places in the factors should be equal to the number of decimal places in the product. Okay, let us look at this example. Multiply 375 thousandths times 346. So we align them vertically. So no need to align the decimal points because we are going to count the number of decimal places later on in our final answer. Okay, so we multiply like we are multiplying whole numbers. So 6 times 5 first is equal to 30. So 0 and then carry 3. 6 times 7 is 42 plus 3. So that is 45. 6 times 3 is 18 plus 4. So we have 22. 6 times 0 is 0 plus 2. So we have 2. Next, 4 times 5 is equal to 20. 4 times 7 is equal to 28 plus 2, so we have 30. 4 times 3 is equal to 12 plus 3, so we have 15. And 4 times 0 is equal to 0 plus 1, so we have 1. Last, 3 times 5 is equal to 15, carry 1. 3 times 7 is equal to 21 plus 1, so 22. That should be 2. Wait. Let us change. Okay, let me check that again. So 3 times 5 is equal to 15. Am I right? 3 times 5 is equal to 15. And then 3 times 7 is equal to 21 plus 1. So it should be 22. Yeah, that's right. So instead of 1, this should be 2. And then 3 times 3 is equal to 9 plus 2. So we have 11. it should be 11. This should be 1. And then 3 times 0 is equal to 3 times 0 is equal to 0 plus 1. So we have 1. Okay. So we have 1, 1, 2, 5. We can now add the numbers. So we have 0, 5 plus 0 is 5, 2 plus 5 is 7, 2 plus 5 plus 2 is 9, 1 plus 1 is 2, and 1, bring down 1. Now we count the number of decimal places. So for this factor, we have 3. And for this factor, it is a whole number, so we will only consider the 3 decimal places. So there you go. There are 3 decimal places, so it means that we will move, if the decimal place is here, we will move 3 places to the left. Okay, so the final answer is 129.750. Next example, we have 300 times 200. So we have 0.03 times 0.02. Again, we multiply them as if they are whole numbers. 2 times 3 is 6. And then that will all be 0. It will also be 0. So you can actually stop here. And no need to put this part. But for our example, I have just placed it there. Okay. So when we add all of those, that is the result, and then count the number of decimal places. There are 2 decimal places here, plus 2 decimal places here. That's why we have a total of 4. So starting from here, we will count 4 decimal places. So 1, 2, 3, 4. The decimal point should be here. Okay, so here is our final answer. The product of 300s and 200s is 6 10,000s. This time we are going to divide decimals. Here are the steps that we need to follow. To divide decimals, multiply the divisor by a power of 10 or move the decimal point to the right to make the decimal number a whole number. Multiply the dividend by the same power of 10 or move the decimal point to the right as many places as move the decimal point of the divisor. And then, next, divide the decimals as you would divide whole numbers. Annex zeros to the right of the decimal point of the dividend until the quotient terminates or the digits in the quotient repeats. Place the decimal point in the quotient directly above the decimal point of the dividend. So those are the steps that we need to follow for us to solve or find the answer to our examples. Example A, we will divide 84 by 1.2. So we are going to place it in the division symbol. So 84 is inside since it is the dividend, and 1.2 is outside the divisor. And then we can we must make our divisor a whole number first. So how do we do that? We move our decimal place to the right. Okay, since we are moving it one place to the right, we will also do that with our dividend. Okay, and since there is no digit here in the last part, so we have to annex a 0. Okay, now we are dividing 840 by 12. Can now divide. So 8 divided by 12 cannot be, so we will take 2 digits. 84 divided by 12 is 7, and 7 times 12 is equal to 84. Subtract 84 minus 84, the result is 0. Don't forget that we still have another 0, so bring it down. 0 divided by 12 is equal to 0. And 0 times 12 is equal to 0 again. And subtract them, the result is 0. It means that the quotient of 84 and 1.2 is 70. Example B, we are going to divide 269 and 75 hundredths by 5. So again, we write it here like this, and then we can divide because there is no problem with our divisor. It is already a whole number. So 2 cannot be divided by 5, so we will take 2 digits. 26 divided by 5 is 5. 5 times 5 is 25. Subtract them, so we have 1. Bring down 9. Next, 19 divided by 5 is equal to 3. 3 times 5 is equal to 15. And when we subtract them, the result is 4. Bring down 7. 47 divided by 5 is 9. 9 times 5 is equal to 45. And then subtract. So 47 minus 45 is 2. And then bring down 5. So we have 25 divided by 5. The result is 5. 5 times 5 is equal to 25. And 25 minus 25 is 0. Now for our decimal point, we just have to align it here with the decimal point of our dividend. So 53.95 is all right. For the next part of our discussion, so let us look into some worded problems involving the operations on rational numbers. For our solutions, you can use this method or you can use this acronym. So we are going to use AGONSA. Okay, so A for what is asked, G for the given, O for the operation, N for number sentence, S for the solution, and A for final answer. By using this acronym, you can fully answer what is necessary in the problem solving given or in the worded problem given. Okay, so for problem number 1, we have here the freshman convention was held at the activity center with 12,567 seats. If 120 seats were not occupied, how many were occupied? So let's have A for what is asked. So the question there is how many seats were occupied? And then the given is the total number of seats is 12,567 and the number of unoccupied seats is 120. Now our operation is subtraction since we have to subtract for us to get our answer. Okay, subtract the number of seats with that of the unoccupied seats. And then for number sentence, of course, we write it as 12,567 minus 120. And subtracting the two, so 12,567 minus 120, so 7 minus 0 is 7. 6 minus 2 is 4. 5 minus 1 is 4. And bring down 2 as well as 1. So the final answer here is 12,447. And we say for the final answer, 12,447 seats were occupied in the convention center. Problem number 2. Problem number 3 says there, how many pieces of ribbon can you cut from 10 meters if each piece is 4 centimeters long? Okay, so what is asked first? How many pieces of ribbon can you cut from 10 meters if each piece is 4 centimeters long? For the given, so the total length is 10 meters and the length of each piece of ribbon is 4 centimeters. As you can see here, we have different units. So we have meters and centimeters. So we can convert centimeters to meters right away. So 4 centimeters is equivalent to 4 over 100 meters, or in decimal, we can write that as 0.04 meters. And for operation, of course, we are going to use division. Number sentence, 10 divided by 4 over 10, or we can write 10 divided by 0.04. And then for the solution, we have 10 divided by 4 over 10, but since it is division, we have to change the operation into multiplication and find the reciprocal of 4 over 100, which is 100 over 4. We can then cancel 100 and 4 because they are both divisible by 4. 100 divided by 4 is equal to 25. 4 divided by 4 is equal to 1. On the other hand, 10 here has a denominator of 1. So we can now multiply. 10 times 25 is 250, and 1 times 1 is equal to 1. So we don't have to write that. Our final answer is 20. So for the final answer, we can say that you can cut 250 pieces of ribbon from 10 meters, or from a cloth or any material that is 10 meters long. Problem number 4. Peter bought 3/4 kilograms of corn beets. He repacked this into 1/8 kilogram each. How many packs of corn beets was he able to make? Okay, so what is asked in the problem is that how many packs of corn beets can Peter make? For the given, the total weight is 3/4 kilogram, and the weight per pack is 1/8. Of course, our operation here is division because we are going to divide the corn bits into different packs, different weights, different packs with 1/8 kilograms as its weight. And then number sentence, so we have 3/4 divided by 1/8. And for the solution, again, this is division, so we are going to change the operation into multiplication and then multiply our dividend with the reciprocal of the divisor, which is 8 over 1. We can cancel 4 and 8 because they are both divisible by 4. 8 divided by 4 is 2, and 4 divided by 4 is 1. Multiply, so 3 times 2 is equal to 6. 1 times 1 is 1, so we don't have to put 1 already. Our final answer is 6. So we can say Peter can make 6 packs of corn beets from the 3/4 kilograms of corn beets that he bought. That's it for our lesson for today. Our next lesson is on roots of numbers. Until next time, goodbye.